Welcome dear students. Today in this video we are going to discuss the perceptron model. That is the first step towards artificial intelligence. Through this we will learn how a single mathematical rule taught machines to make decisions. So how does AI makes decision? This we will see. If we talk about human thinking, it has a mess in the mind. Maybe possible you may get confused. You have so many other answers, but AI does not think like we do. It almost has like a most fundamental level AI uses, but it does not debate or ponder. It makes rapid, calculated binary choices as yes or no, 1 or 0, as yes means 1 for true and 0 for false. If we talk about the real world binary classification, if we see our face is detected, so we give input as a for our face detection system, and the task of AI is to match the identity. Now whether the door will open or not, it depends on access granted 1 or 0. If identity match is giving you the permission, if it is true, then your access is granted. So you can see the things which we can see is coming as 1 or 0. Then we have second is the message analysis, this one. So for mail we have spam or not spam. So output we are getting after the AI task performed, whether the mail is spam or not spam, we are getting in the message box it is the spam mail or it will go to the inbox if it is not spam. Again, one is if the task of AI is for risk assessment and it review the application, then the output may be the application is approved or rejected depending on its classification. Then we have a input scan, that means anomaly check whether the person is diseased person or a healthy person. It depends, and again you can see it is giving us answer only as yes or no. The simplest mathematical model that performs this yes-no classification is the perceptron model. If we talk about the anatomy of a perceptron model, it starts from the raw data entering to the system. Say we can have n number of inputs. So we have marked there x1, x2, x3 and the weights assigned to this. These are the golden multipliers. It is multiplying the scale of input data entered to the system. So we have 3 inputs and we have 3 weights. So these are the golden multipliers as weight that determine importance of each input. One, we have a bias, that is a baseline adjustment to shift the decision boundary, that is added to the summation. Then we have summation, the core node where all weighted data is added together. After that it is passed through a activation function. The final, it's like a final gatekeeper that gives you output as 1 or 0, that we will see how we find out whether it is 1 or 0 in our coming slides. So let's see formalizing the math here. So we have x1, x2, x3 are input. So we are finding the net input for this, that is summation of x into w plus b. Bias is z. So if we talk about the step-by-step method, here each input x by its assigned weight w, then sum, add all those weighted inputs together as a sum, then add bias to calculate the final net input. After that, the activation function, the activation gate that makes the decision. The perceptron compares the net input to 0 to make its final choice as yes or no. So when we talk about it, net input is given, and if net input is greater than equal to 0, it means it is more than 0, then output will be 1. That is yes. And if net input is less than 0 and gate turns red, that means it's just an example. If gate is opening, we have just marked the color as green. If gate is not closed, it marks as the warning as red here, just for symbol. So if net input is less than 0, then output will be 0 and answer will be no. Now let's see this guided problem step by step. Here we have two tasks, input task where x1 is 2, x2 is 1. And we have W1 0.6 and weighted average is 0.5. And bias added here is the -1. So now when you solve it, the value is coming as 1.2 and 0.5 here. After that, when we add this as a summation and bias, so bias is added here. Bias is added, so net input becomes as 1.7. When we add this bias, as bias is negative here, the net input coming out to be 0.7. So after applying all this, we get the net input. So is 0.7 is greater than equal to 0? Yes. So output will be 1 for the perceptron fires. Now your turn. X1 is 3 here, X2 is 2. Although here we have given some values to X1 and X2. Otherwise you can have as a binary decision for X1 and X2. Sometimes we give the binary decision as 1. X1 is 1, that means the decision is tree, like do I carry umbrella? 1 for yes and 0 for no. Do I have jacket? 1 for yes, 0 for no. So it is absolutely correct if we have x1 as 1 or 0. Just for example, we are giving here 3 and 2 values for the task. Sometimes we have some numbers also in the model. That's why I have given here some values. So find out the net input and apply the activation rule before we move to the next slide. So just find out, we are taking a little pause here. Absolutely okay. Now you have got the answer. So let's break down this. 3 into 0.4. Like if you see here, you are multiplying this step 1. Bias 1.2 plus 0.6, 1.8. Then you added the bias. You got the 0.8. Now output is 1. Yes. Hope you got this correct. You can write in the comment section if you got the correct output. So let's see the limitation of single neuron. The single neuron are linearly separable. A single perceptron can solve simple problems where data can be separated by one straight line. Where it's not, one neuron is not enough when we need non-linear pattern like complex data to handle. So it handles linear separable data very comfortably. So the evolution of multi-layer neural network, we already seen the neural network has 3 parts: input layer, hidden layer and output layer, where input layer has features and output layer gives you labeled output. In between we have so many hidden layers which work for multiple multi-layer, and we can link multiple perceptrons together. So to solve incredibly complex tasks like recognizing a human face or driving a car, we must link multiple perceptrons together. So by combining them into hidden layers, artificial intelligence can draw complex or curved decision boundaries to understand the messy real worlds. Here we are using multi-layer neural network where hidden layers are more. So this is a small master cheat sheet for you. And we have here input, weight, summation, bias is added, and if output is 1 if net input is greater than equal to 0, and output becomes 0 if it is less than 0. So in the next section we are going to solve some perceptron model questions, and here I will end my video with this. You are building the future every complex AI system transforming our world today with this fundamental concept, learning how to make a single mathematical binary decision. Keep exploring, keep learning and keep building the future with AI. So in the comment section, I have shared a link of assignment of perceptron model. You can find out that in the description box, and you can do that solved and unsolved exercise also. Thank you so much.